All right. So the lecture was an idea to explore some of the things in Python that maybe not everybody has seen or that are, interesting and useful, but if you don't know about them, you'll never use them. So I'm basically, for the next 5-6 lectures, I will explore some of the hidden methods in Python, some of the things that you might want to know, like how to create your own meta classes, how to generate an API dynamically, like Django does for the database APIs, things like this that are not really clear from the start. Then the last part of the class, I will start to talk about multi-threading and then multiprocessing, and see maybe we can do an example together of an application that uses multiprocessing, like, I don't know, a distributed API or something like that.
We can propose
an example
to solve the multiprocessing.
Or a machine learning workers factory that distributes stuff on CPU on different computers and then distribute the loading and like that. Something of this kind. But before we go there, today I wanted to give a bit of an introduction to, again, what we might know already about Python, but it makes sense to repeat. Then give an introduction to the life cycles of classes in Python. So what happens when you create a new class, what happens when you create a new instance, and how can you intervene in this process. And then explain some of the so-called double under methods. So this underscore init, for example, is a double underscore method, but there are many more, and they are called dunder methods. So if you see this in any forum, you know what they're talking about. So Python basics. I mean, strongly typed. This might be a surprise for some, but Python is actually a strongly typed language. If you do something with the wrong type, it's gonna complain about it. And it's not going to change, just try to use the pointer to this variable in any possible way. But what makes the confusion is that there is an implicit typization and there is no type checking when you pass the argument to a function. So while it's still strongly typed, there is no checking by a compiler, by the interpreter at argument passing. Also, yeah, it's interpreter. Usually because there are compiled version of Python, but we usually use the C Python. Nobody, I think, ever bother here to actually compile Python. I think you did, of course. And it's high level, which means that there is no control over memory allocation, at least not easily, and it's removed from the actual hardware. When I mean it's removed from the actual hardware, everything is an object. And when I say everything is an object, I mean that, for example, everything is allocated in the heap to start with, even parameters of functions, even the function itself. So the heap is the dynamically allocated space of memory, which in C you access by creating a space memory with malloc, and then you release the memory. That's what the heap is. The stack is the other part of the memory you can use in programming, is where the function is saved, the parameters, the static variables, and so on. Well, in Python, everything, also the stuff that should usually go into the stack, is in a virtual stack, which is in the heap. So it's all allocated there. Classes themselves are objects. So when you create a class, you actually create a new instance of a class type, which is a special class that is a bit of a cheat by the interpreter, by the implementation of Python, of C Python. So it has special implementation of their own init and new method, but basically it's another class. So whenever you implement a new class, you create a new instance of the class type. And you can also change the way this is done by defining what is the class of your class, and we'll see it in the next lecture, which is meta classing. Int, strs, and all basically standard types are also objects. They are, again, there's a bit of a cheat inside because you cannot extend them in typical ways. We'll see later, but they are actually objects like everything else. And functions, methods, are also objects. So when you assign a method to a class, that method is an object in the heap, and the class knows the pointer to the method, and that's it, right? So just to summarize, everything is an object. And what does that make possible? Well, first and foremost, you can assign a method at runtime. I mean, just the typical, the very, very typical use in Python is that you have a library, and we'll see later, and you just want to change a method or to add a method to it. You just say object.method equal to a function, and there you have it. So the class that you got from somewhere else now is a new method, and it's your method. You can have classes which are instances of classes. So that's what I said before. There's a meta-classing thing. It's useful for several things, like, for example, creating APIs where you don't know what methods are going to be there until you parse some kind of definition, some kind of, for example, hypertext language like XML or anything like a configuration, and then you can create the methods at runtime. Very useful for that. You can have also functions that treat different kind of objects, like, for example, the parameters can be an int, a string, a very complex object, can even be a class. And you don't have to actually rewrite this method again. You can basically simplify to what you really care about. We'll see that later. And yes, and you can write code that works on many different types, legal or no modification. So particularly if you're using it with types that have, say, the same methods, but they are not connected by a common ancestor or by any kind of formal connection, you can still use one method to treat them all. You don't really have to create this connection artificially. Which brings us to the next topic, overloading. So a function, as I said, accepts any parameter type. What you can do is, first of all, it falls to you to check that the parameter is the right type. You don't have this in parameter checking when you start a function in Python. And what you do usually is use the method isInstance. And you can also use hinting. So hinting is when you put after the argument, basically like a column and then the type, or you return the type. And then, yeah, it's well documented. You can use it for the editor, to hint to the editor what you want to do, which will give errors in the basically in the checking of the file, and it will be used if you generate documentation from it. So if you generate automatic API documentation, but the interpreter doesn't care. You still pass a float here or a string or whatever you want, and the interpreter will take it.
So, question. So when you hint a type and later on connecting the meta type, so when you do the conversion behind that, whenever the conversion starts.
What do you mean? You need to type and then another type. What do you mean to type?
So for example, int, and then later on I want to convert it to double.
So if you pass a double here, if you pass a double, the interpreter will not care. This is for the interpreter, this doesn't exist. So you just take it as a double at face value, and then whatever happens later, if there is an exception because of an error, because you do with a double something that you're not supposed to do, then you get that error. But the interpreter doesn't care if you pass the double. This is really just for editor, auto-completion, and for documentation. That's all it is to it.
But if you do the same thing with a class, like you say, has an object that is of this class, then it will complain if it's not from the class. Actually,
Only the editor.
Only the editor.
yeah, only the editor.
The interpreter will not do anything. So, I mean, again, whatever you put here is just aimed for the editor and for the documentation to create the API documentation properly. I mean, it's good practice. I don't do it most of the time, I say, but it's good practice.
Are there linting tools available to check this as well from the command line, not from the editor?
I don't know, to be honest. The debugging tools for, I mean, which command line tools?
Linting tools.
No, I don't know.
Okay.
So monkey patching. Monkey patching is overwriting or adding an external library class at runtime. So why would you do that? You get a library, for example, from Unity or from NumPy, you get a class, and you want to write a method for that class that works on every object of that class. And what you do is usually you extend the class in another language, you create like a my NumPy array, for example, right? And then on that, you actually add a new method, and when you get the object, you would then create a new object by initializing with an instance of the object that you received, create a new object, which is yours, and now you have the method, right? Well, in Python, you can skip all this and just say the class that you want from the library dot my method equal to whatever you want. And so this is a complete alternative to extending classes from other people. It is considered dirty, but it's extremely useful, and it shortens the the part of coding that you need to do every time you need to use this method, because you have to convert the objects, you need to do all this patching. We'll see an example later on in your code, but yeah, the concept is really easy. The other thing I want to introduce before we go to the demos is dunder methods. So these are double underscore methods, and there are several. So call is the method that transforms your object, whatever that is, in a function. So if an object has a method call, you can put the parentheses on top of the instance, so to say, to the right of the instance, and you can call it and pass it parameters. And what happens is defined here. So you can create your object and then add the call method, and it is now also a function. Dict is a good introspection method. It tells you basically every member of that particular object. That we see what it really means, because you must be careful. If you have a class, let's say, that has several methods, these are members of the class, not of your instance. If you have then an instance and you have defined a variable in the instance and you call dict, you will not see the methods of the class. You will only see the members of the instance, which is that variable, the only variable, and so on and so forth. So you can go up until you get to type, and then the story ends because there's nothing else on top of type. But you can do the dict of all the pyramid of classes on top of your instance. Class is also another dunder method. You can call it and it will retrieve the class of the instance. That's nothing particular there. Then you have the name. This is usually used with class, which will give you the class, the name of the class itself. And it is another dunder method which is usually very useful, particularly in debugging SDR. So if you implemented this method, whenever you print the object, the instance of your class, which implements this method, it will use this to convert it to a string. So this method must return a string. Now, there are other options here, and there are several conventions to what to do with different coding. You go and look at if you're interested, go and look at the standard documentation. But the point is, this is 99% of the case. You just implement this with as argument self, and you're done. You don't really have to care about encoding or anything else.
One question.
Yep.
What's the difference between the call function and the like getter and setter stuff from C?
Very different. So if you have class A, right, and a member, let's say whatever bar, okay, that is a member of this class, a getter will basically implement a dot a instance dot bar, right, equal to 1. That's a setter, and the getter will implement a dot bar. Okay. What I'm talking about here is implementing a parenthesis, right? So I can call the instance with parameters, and whatever I do here, it will be passed to my call, and basically return whatever I return in call.
Okay.
That's how it gets used. So this is what is implemented for objects that are functions or methods. They basically have a call. That's all. So actually, I mean, the difference between functions, normal objects, classes is really what you call syntactic sugar. I mean, you can do most of the things that you do with a function, with another object, and the same goes for a class and so on. So bool is also an interesting one, because if you're checking if something is true or false, and you pass it an instance of the object, what the if does, for example, is check if the object as the object class has a bool method, and then calls that bool method. And if the bool method returns true, then it's true, otherwise it's false. So you can implement your own type true false checking for any object that you want. For example, if you want your instances to check some internal variable, if it is empty or not, and then decide if it's true or false, you can do it.
Why is it different? Because in few slides before, you also mentioned a function that you can check the type of the variable.
Right. So type checks existence, right?
Yeah.
Existence checks what's the type, so what's the class basically of this instance. This one checks basically if in an if, right, you want that instance to be converted to true or to false.
But this is not always possible, right?
Well, if you implement this method, it's up to you. That's what I'm saying. So if you have a need and you check, you say if 0, then do something. But you have to define is 0 false, is 0 true. It depends on real convention. Here you set the convention. For your classes, you can set the conventions for true or false.
Okay.
Okay.
I have a question. So
Yeah.
what's the meaning of object class? How can we use the class?
So if you, for example, in this example, A underscore class, okay, underscore, remember, is equal to A,
Okay.
right?
So just can get the class of this object.
Exactly. And if you take big A underscore class, remember, it will give you type. Because type is the class of every class, unless you specify otherwise, and so on. Type is of the class type. That's a bit of a trick, but it's implemented directly in the interpreter. So there's another set of tandem methods, which we'll see then in an example as well. And these are the container tandem methods. So these are what you use to implement your own containers, collections, classes. If you want to implement a list, an array, a dictionary, and all these kind of things, use this. So set items basically is called when you do whatever with self with a key equal to. You try to assign it to this, then it will call set items with the key that you give it and self. And the value, of course, right? You have also the get items, which will do the same when you're evaluating self.key. Sorry.
Then the self and the comma and key, what does it mean?
So, for example, if you have an array and you want to array item number 0,
the position, right?
That's with the position, but could also be a string. Could be whatever you want. It could be an entire list. The point is whatever you want to happen, you implement it here. For the simple example is an integer, for example, then in arrays you get the item at position of that integer. But again, you implement it here, you do whatever you want with that. Same goes with get item, same strategy. Then you have delete item so that you can remove items from your collection, and that's implemented in that. Yeah.
So if you implement the function set item and get item, do you create the overload operator for the?
It is created for you, so you can then use the overload of
Okay, cool.
from that.
No, you get this.
So
It's basically like the call method. If you implement set item, then you can use the bracket.
you can use this.
Okay.
Then you can use this basically.
If so, for set you can only do the assignment. If you
Exactly.
implement the get as well,
Then you have the other way around, right?
Okay, cool. And delete, that is a different one then, right?
Delete is to remove the items. We'll see how it gets used in the example, but it's basically using the del operator.
Okay, just del and then on the.
And that del and whatever slice from the array that you want to remove it, you can do it in one interaction. Then you have contains. Same story, you pass it an item, why an item, and not the key, because it depends on what you have underlined, right? It could be a value, it could be a key, that's up to you. You need to understand what is inside. I mean, if you have a dictionary, for example, you want to delete a position in a dictionary, you will pass it the key. If you have an array, you will pass it the value, right? You don't care about I mean, if you have a set, let's take an even easier example. If you have a set, you will pass it the value because you don't know how they're ordered. For an array, it's up to you. You want to actually pass it the position or you want to pass it the value that you have to decide in here, right? That's your decision again.
And if you implement the contains, then you can do the
In.
blah blah in.
Exactly. So again, this is all syntactic sugar. You can just do it with all your own methods, but it's easier than to program if you do it like that. iter is also what you use when you start doing for a in my class, then it will basically call iter. And here you should use not return but yield. We'll see that later, right? And yeah, and that's about it. Sorry, wrong direction. As the Grizzly said, bear with me. Sorry, bad joke. So, object lifecycle. What happens when you create a class? So, first of all, pass. Who doesn't know pass? Okay. Pass is basically what you write when you don't want to write anything, but you have to give a body to this class, for example, or a function, whatever else. It's an empty parenthesis. In the other languages, it's equivalent to empty brackets. Right? So pass, because I didn't want to implement the class, I just want to create it, and then I want to create an instance of it. So what happens when I do this? First, yeah. Okay. So the first thing that happens is that the new method of tho gets called, and this should return a new instance of the class tho. However, it's created, you have to return it here if you implement new. So if you don't, type will take care of it, and type will get called with the name tho and will return a basic brand new object for you that you can then initialize with the next method.
So this is whenever you create a class, so this method exists, right?
It happens here. Yeah, if you create a class, this class is a method new, which is implemented by type. That's the standard one.
So something like I can also write bar equals to full dot space new. I can also write in that way.
If I mean, you don't want to call it. This method is not for you to call, it's for the interpreter to call. You implement it if you want to override it. Otherwise, if you want to call it, you just do this, right? I mean, all we have done here is basically implementing ints for the interpreter on how to effectively use Python grammar on our classes, and that's the same case.
Something I can understand some of this kind of methods as so-called default. So whenever you create a class, they are there, and you do not change that, and it is there.
Yeah, I mean, this can be used to implement a singleton or a factory or other kind of thing. We'll see later how we get this to, we use this to implement a singleton in a particular example. Then once the object exists, then the init method of the object, not of the class, this is a class method, this is a normal method, right? The init method of the object gets called, and it initializes, it's called, initialize the instances, right? So, and here you do all the things like creating the variable members. You've done this 1,000 times if you use Python, right? And then, less known, there's a del method where that it gets called to destroy the instances. Now, this is usually something you don't have to care about, but if you care about managing resources that are not possible to be managed automatically by the interpreter, you probably have to implement it. Be careful, it can be called at any time, and we'll see that later. And it's not safe to call if you have lock on some resources from other threads or processes, because you really don't know when it's called and what it does. It can be called at garbage collection. It can be called when you reset the interpreter before you start a new script. It can be called in any possible situation.
So in this case, so the second function is for initialization, but we didn't write anything in the class full. So what it is actually doing?
Sorry, the init function.
Yeah, because basically initialization, you need to, if I understand it correctly, you need to decide how you want to initialize it. So what do you mean by initialize mean? But there's nothing in the class now. So what it is doing?
So if you, for example, if you want to initialize a new string and you pass it an integer, you want to parse that integer into a string. That's what you do in the initialization.
So what I'm trying to say
but
is that we need to write somewhere else to define what do you mean by initialization. For example, set some parameter to somewhere.
Yes, and that you do in the init function.
But then the user need to implement it.
Yes, the user needs to implement it. And so these are all methods that you can implement. You don't need to implement it. You can implement it. And so now let's talk about one application, for example, of this user lifecycle. Now you want to do it. First of all, what is a singleton? Singleton is a class that has a single instance. So whenever you access this instance, you want to access exactly that instance and not create a new one. For example, because okay. First of all, of course, it's implemented using the new, right? Because you have control of what happens when you create a new instance. So you can actually return the same instance that you had before. And that's how we're going to implement it. And why it is useful? Well, it's useful to control access, for example, to hardware resources, to create factories. You can use the same style, or to have access to software resources that are constrained, for example, database connection, something like that. You could have a singleton that is, the factory for the connections that controls when and how this connection get created or reused. And you don't want somebody to create a new factory, but you want always to reuse the same factory. So this is for the theoretical part. Now let's go to something more fun. Overloading. So let's make this example to start. Remember, we can send anything that we want to the to a function. So what I did here is implement a little function that checks for prime numbers. So if you pass it a number, if number is prime, it will tell you true, otherwise it will tell you false. So there's two things that I do here. First of all, I assert that my instance is an int, because if I don't do it, I can pass the float and it works. And we'll see it down here. Actually, let's do it right away. So ignore the rest for now. But if I run it, you will see. Wait a second. Let's run it from the start, otherwise it's so assertion error, right? It didn't get to check my code here. It didn't get to check this stuff because when I passed it 11.0, it did the assertion here and it failed. If I remove this, and I run it again, well, now it actually worked. If you see at the end, I get another 11.0 is prime, it's true, right? So you can pass it, as you see, I can pass it the float and it will just run. And I don't care if it's a float in this case, because I'm doing operations that are valid at any number. But if I want to really check, I need to do actually an assertion or an if and then raise an exception or something like that. So, I mean, the algorithms is really stupid, but maybe it helps to go through a few of these things. First of all, I'm importing from math, ceil, and square roots. This is just normal mathematics. Range, if you don't know it, in this case, I'm just giving it a base and a max, and then I'm checking, everything for every number that is in this range. So from 2 to the square root of the number plus 1, and then I check if it's divisible. Just basically what I'm doing, right? So what is interesting here is this print. Let's see again what it does. It gives you the numbers that are in the range. So, and you'll see a lot this star in when you call, for example, a method in Python, you see star args usually. Star args, the star operator basically converts a collection into its elements. So it expands the arguments. You can pass it as a list, and it will then put them in the right slots for you. If you do 2 stars, it will convert the dictionary to then their keywords assignment of the arguments inside the function, right? So it's useful to have seen at least once here. Well, then, the rest of the algorithm is pretty easy. What I wanted to show you is how to use this fact that I can overload the function with different types. So what I'm doing here is I'm using isInstance, and I check if the instance is a string. If it is a string, I actually go and first convert it to int. I try, and then accept. So if there is an error, I will then parse here, cannot parse. I will then raise a new error called cannot parse whatever you pass me. And this is also something that is new in Python 3 that you might want to use, is formatting a string, pretty easy. You put an F in front of it, and then you put every value in curly brackets, and then it just gets evaluated at runtime for you.
A stupid question. What is characterizing the boundary of the function in if structure and for structure?
Okay, so good question. I didn't say that. Basically, once you start, a new scope, for example, by using the column here, you start at a new indent, and everything that is at that indent is going to be within the scope. When you start a new nested scope, you start a new indent again, and so on. When you remove that indent, you go to the previous scope, and so on.
Okay, so it means, so actually is that space characterized in the boundary?
Exactly. So which means you have to be careful how you indent your code, which is makes it very readable.
I've heard that point about Python, but now I know. Yeah.
All right. So now what I'm doing here is, again, something that you see a lot in Python, try and accept. I mean, you can check and do things with your result of the if. Usually a very Python way to do things is just try to do it, see if the interpreter chokes on it, and if it does, then do an alternative. This is usually very diffuse in Python programming. So anyway, if I am
in this case, what would be the error? If the my number is not convertible to an int?
If I have a string, but the string includes stuff that is not really an integer, then int will not be able to parse it, right? And then it cannot convert, and then the error is really not that it's not a string, but that the format of the string is wrong, right? So you want to then send cannot parse it, do something about it. But if I don't have either a string or an int, then I actually raise another value error, which is this accept only strings and ints, right? So that will take care, for example, of my problem with the float, which is an artificial problem. I mean, of course, you can check if a float is a prime if the float doesn't have decimals. But the point is, it's an example of how you can then check for type, right? And as well as for what's inside the type. And usually, if you want to check for type, you actually use is-instance. But if you want to check inside, you just try. Just try, and if it doesn't work, you do something else in the except. This is usually the Pythonic way to do it. So if we run it all now,
I don't get why in the no, I get it. Sorry.
So if I run it all now, we get an error that is exactly prime accept only ints and string, because I try to pass it, which I activated right now. I try to pass it this stuff here, 11.0, directly to prime. I mean, in the previous call, I passed it to prime int, so it was choking on my assert or just computing it. But if I pass it directly to prime, then it goes exactly through this cascade of if, and it ends in the error, and then it rises the value.
So in the print code, what does it mean by the if, and what does it mean by the bracket?
Right. So
yeah, okay, yeah, it's also
F means that this is a formatted string.
Okay.
Right. So if you prepend this F to a string, you can insert values in the string that they can be computed at interpretation time, so the evaluation time, and not at compile time. So cannot parse bracket my number. We will put inside here the value of my number. So let's make an example. If I want to say, is this ISD prime, right? I'm pretty sure that we'll choke on it. That's it. And that's why you should never do examples live. All right. So I don't know why it's not now printing. It's probably suppressed by the interpretation of the string. Anyway, this is basically why it's there. So that if you have an argument there, it basically writes there. Yeah. Exactly.
You can also have your string,
but
curly brackets, and dot format, and then in brackets.
But if you see this, this is what's happening also in the other examples. Let me show. 4 is prime, false. False is exactly this, right?
Mm-hmm.
So it is evaluating it to false and then printing it in the string.
Yeah.
Makes
In
sense?
this case, how would you do it? For example, if you wanted a float to show only the first two after the.
You have all this percentage, the two, yeah, you can use them there. You can use all these modifiers as well. So Any question on this? Otherwise, we can move on to the next example. Okay, then monkey patching. So let's see it in action. So here I have, let's first run it and clear it. So we can do the rest. So here I have basically created a class, which doesn't do much, it just prints the argument that I pass with the function bar. And then what I do is I call it, and we see that it just prints this one. Then I define a new function that prints modified print R1. And then I call again, I assign it as bar to my original class. And then I call again the instance that I created before. Now, let's see what happens. First, I get the first print. And then when I call it again on the object, I get the redefined print. So you see the instance has been defined actually before I changed the class behavior. The instance is being defined up here. But when I change the behavior of the class by assigning the new bar function, then even if the instance was created before, it calls my new function. So again, if you have a library that gives you values and you don't have a chance to initialize your class before the values get created, you can still patch them and change the behavior of the values on the fly.
Can you also assign new functions and not override?
Absolutely, absolutely. You can assign, and I will not do a demo now live because I'm sure I will mess something up. You can assign a completely new function to the for class on the go. Right? It's the same as defining them in the class definition.
So after the code has been finished, so finished execution, so it returns to its original definition, right? Because it only redefining on the fly.
There is no such thing as return. The interpreter gets shut down. There is no instance of the class foo anymore.
Okay.
Right? I mean, the point is the class foo is an object in the heap, and it's a dynamic object. So whenever you change the method, it stays that way.
Okay.
Until you remove it from the heap. So if you redefine the class foo, then it's of course redefined with a different set of methods, the one that you defined it with, right?
Can you get rid of the self in there? Or do you need to in the front one? Can you assign static functions?
You can put anything there, but it must be an argument. Because the function, when you use a function as a method, the first argument is assigned to the instance of the object that you call the function on.
Could you put an add static method on top and then remove the self?
The add static, I don't know, I never tried. Interesting.
Because that would be interesting if you can assign static methods with multi-patching, but you should be able to.
I should be able, yeah. I didn't look inside the add static method what it does exactly, so it might show up on that. I don't know. I would need to try.
So this is another question. So this is a class globally or only within a specific function?
So just a second. I'm pretty sure that if you don't put the self, you put just R1, and then you don't call it on foo small cat, but on foo big cat, then it's basically a static method. You don't have to actually bother with the decorator at all. Because that's what it does. It's just assign it to the class as a member, and it's a function. And when you call it on the class and not on the object, doesn't pass the first argument, so it just gets used like that.
But
again,
you still want to call static methods on the objects.
Yeah, but it's basically just syntactic sugar at the end, right? The only thing that difference is that it doesn't have a self. Sorry, let's go back.
Yeah, so my question is that, so this class, for example, is a public class and it is called within a function, for example, and then if I redefine one of the function with one of the function of this class within this function, so after you finish executing the function and going out, and then actually so what I'm trying to say is that is this change only valid within the function I change it, or if
this is not within, I didn't change it within the function. I changed it at base level, at global level.
I mean, if I call it, if I change it,
If you change it within a particular scope, no. This is a reference to a global symbol that defines what this class foo is. And this is nothing else than a pointer to that object in memory. So if I take this pointer, which is globally defined, and I change its method, it's globally defined for everybody done with a new method.
to sum up is that whenever you change like that, you change it globally.
Yes, absolutely.
And that's why it's dirty, right? Because wherever
It's
you
not
do
documented.
it will just do.
Yeah. So, I mean, if somebody else has to write code on top of you and reads the original documentation of the full class, it will go, oh, it just brings the argument. And then if it gets this, say, where is this coming from? Well, it's coming from you because you're also using the library in the same program and you're changing the behavior. No, there's nothing like that. Actually, there is a convention that you put an underscore on it, that's an interpreter, and you can still do whatever you want.
What's up?
All right, that was a serial effect. Yeah, let's close
Quick
this
question.
one.
Quick question. If you
Yes.
line 12 and 14, if you change bar to best, can you add a new function to the class?
Yes.
Is it technically possible to, let's say, seal a class or that it?
Like this?
Yeah, for example.
Yeah, absolutely. There we go. You can add methods, you can change methods. So you can define the old class at runtime if you want.
Is it possible to seal a class that I can detect that this is an error?
You can write your own method that does a checksum on the class itself, but I can override it.
Okay.
Let's just get rid of the self there and let's just see.
Yeah.
Of course. So let's try to get rid of the self. I take no responsibility for what happens from now on. And let's call it on, this will give our.
It's fine, just run it.
So function takes one positional argument where two are given. Because the first one is always self, so it gets assigned.
If you put an add static method over it.
So
Above the function.
Yep, on it.
I think it was the definition, not
Yeah.
just 2 lines.
Yep, you're right. Let's see. Then it works.
Aha, good. Okay, thanks.
So, yeah, or you can call it on full big case, and then it's the same.
And what again was what can you not do with when the method is static?
The static method is basically not called on the instance, but on. I'm just reverting back because I want to save this stuff. The static method is not called on the instance, but on the class. That's why it's static. Okay.
When you define it as a static function and call it without the instance or class. So just call it, you have the definition of function 1. What is happening then? You know, you define function 1 here, and then we just like assign it to a class, and then we call it. And what is happening if you just call function 1 directly?
You can just call it directly. The static.
But also when you define it as a static method.
Yeah. I mean, the static method that doesn't do much.
In this case, if you call it without a class, then
I can still call this, but I need to provide a self.
yeah, that's what
I'm not using it in the function, so I can provide also none, and it will be still working, right?
Basically, for your question, in a static method, you just cannot access self.
Yeah.
You cannot change variable from yourself or
There is
Yeah.
no self
There is no self.
because it's static.
So,
the obvious one, I just want to be.
I mean, again, this stuff here that we are doing is just again syntactic sugar. Behind the scenes, this is still a function, and just a normal function. I'm just calling it and providing, the interpreter is providing for me foo as the first parameter. That's all. There is no special behavior of this function. It's just syntactic sugar because I put my first argument in the front instead of in the brackets. That's the whole difference. Nothing else. I could write everything I do here with just functions without classes, right?
Another question. So here I call it function. So there's no double space at the beginning.
No, because these are normal functions. The double underscore functions are special functions, and they are marked that way because the interpreter gives special meaning to them, right? But it's just a convention. They're functions like everybody else. It's just that they are marked that way so that you can identify them quickly. Okay. Any other question on this? Okay, let's move on. So,
Question.
yep.
If we put an underscore under before func1, then it's a private function, right?
Right. It by convention private.
By
No, you can call it all the time you want. It's just a different name.
But if you put the 2 underscores in front.
It's the same. It's just a convention.
Okay.
No, I think with two is a different. With you only put one, that's just for you to know.
I can call E, I can redefine it, I can do whatever you want with it. 2 underscore, 1 underscore, 0 underscore is just a convention. The interpreter doesn't have the concept of private or protected code.
Okay. I think like also underscore you use it a lot also when like if when you want to use something that the interpreter blocks, like let's say I don't know, you call a function in for example.
So private, the point is if you put an underscore in your functions, or if somebody else put an underscore in the functions, it means that you're not supposed to use them because those are not stable API functions. So they might be changed in the future. That's why you don't want to use them. But there is nothing that prevents you from using it. Nothing, in the interpreter. That's what the point is.
So only decorators are changing the interpreter.
The decorators are again just syntactic sugar. We'll implement the decorator is nothing else as a function that takes a function and spits out a new function, or a class and spits out a new class. It's nothing special, and it's not particular to the interpreter either, right? A decorator is just a function that takes as an argument a function, spits a new function if it's a function decorator. If it is a class decorator, then it takes a class and spits out a new class. Make sense? And you can implement it as a function, open parentheses, you put the class definition inside and spits out the class spec. The fact that you put the at and the name of the decorator is that syntactic sugar to make it more readable, but it's not actually different from a normal function.
Yeah, because the static method was actually changing it, right?
Yes. Static method, it's the same as putting foo equal static method of let's go back and let's say what it means. Static method is the same as doing this func1 equal static method 1. This is exactly the same.
Equals to put it like add static method on top of the function.
Yeah, it's the same as putting the add static method on top. Right? All right, so let's see monkey patching in action. So for example, nothing new here, but just a trivial example of how you want to use it. I have the imported path from pathlib, which is used to access different files. It's the object-oriented way to access files from in Python 3. And what I want to is create a function that gives me name length. Okay? So it's a new function I want to apply directly on path without creating a new class. And what I do is just this. I just define path of name length equal to my function name length, and that's it. Then I can call it.
Define path after the from import path.
Yes.
Okay. So
Right, and it gives me path name length equal 8. Right, so nothing really special about the monkey patching. Let's move on because it's almost the end. I wanted to get to something more interesting, at least to the singleton. We'll keep the container for next time if we don't make it. So this is a bit of a show of what all these methods do. So init, we know it's initializing. Call is basically calling the object, and then we have just one method, for example, my string that prints the object and the bool. Okay, so and then we can see what happens if I use them. First of all, let's check the first two prints. All right, they give the same result. And this is basically because if I define this function as foo f and it returns bar, I can also use the call to call it, which is the same as putting the two parentheses here. So for a function, call is the same as putting the parentheses, but I can define the call also on an object. And I can actually, we'll see it here, I can actually use it here like this. So my call method, I have basically, I'm printing out bar and whatever the value of A is. And I call it with 1, so I expect to print it out bar 1. And there it is. All right, let's clear up so that we don't have to look at it again. So I'm calling the object with no argument and print, it's executing my call method. I can also call if bar else false, which will give me true if this one executed true or false, which is checking in this case if self A is not equal to 0. So this is how I implemented, for example, implemented move, for example. Make sense? Right. So if I call it, it should be giving true. See? And now what we can do is actually check what's inside this class. This is going to be a bit long. So this is actually what's inside my class. And you can see there is a module, which is main. There is a definition of B equals 0. Why? Because up here I defined a class member, B equals 0. This is inside the class and it's not defined inside the init. A is not there, right? If we look at the output, A is nowhere here to be found. A is inside the instance itself. Then I have call because I define the function call. I have method 1 because I define function method 1, and so on and so forth. I have all my methods. And then there are some stuff that are internal, like doc, wait ref, and so on. So these are internal stuff of the interpreter.
So why would I use B or A in the init or outside?
So B is a class member. I initialize it at root level at the class. So it is the same for every instance. And it is part of the class definition, not the instance definition. A, which is defined in the init, is the member of the instance. So it is only valid for that particular instance, and it depends on the value I actually call it with, right? So if I now print the dict of the instance, which is down here, you'll see it's inside there. There it is. That's the only element in the dict, right? So this is how I can introspect my objects.
But can I access B in a method, change it, or add it to the self or something like that?
Yeah, you can change it. Again, for is just an object, so you can change their methods at runtime, like their fields or their members or anything else.
Is it passed? So B is passed to the methods even if it's not in the self.
Well,
Even if they don't get the self.
if you are in the instance, you can always access. Let's look at the example. You can always access this, right? You can always access the class. Sorry, I took the wrong one. You can always access this one here. So now I'm not accessing anymore for dict. I'm accessing bar.class.dict. But the result is the same. I can access all the methods and all the members of for by accessing bar.class.dict. So within the instance, I can always access all the class members and so on and so forth.
If you create two instances of the class for, and you change B in one of them, is it also changing the other?
You cannot create two instances of the class for because for is a global symbol. So when you link that pointer to an instance, that's the definition of for. When you link it to a new definition, it overrides the previous definition. The name for, right?
No, I don't mean the name for it. Can you go back to the code?
Sure.
And just,
so let's say you say for2 equal to 4.
No, I don't mean that.
He wants bar 1.
Oh, bar 2 equal 4/2.
So if you would now change B in one of them, does it change in the other?
So again, if you change it like this, bar dot class dot dot B, then yes.
Then yes. If you just call bar.b.
Yeah, but then it doesn't access actually that B. It creates a new B in the instance. You understand? Now you have an instance member, right? It's not a class member anymore.
And if you just read it, so you print bar.
That might be working. Let's see. That might be working. It should be print 0, right? Yeah, it works because I believe that they inherited the revenue. I've used that a lot of times.
Can you just for fun say var2 dot class dot b equals 1 before?
Var2 dot
Wait, you're not in the.
b. Yeah, it did say console equal to 2, and then we say bar dot b 0.
Okay, and if you do now var2 dot class dot b.
Var2 dot class dot b equal to 3. All right. You like it?
So basically never use this.
But if you use bar dot b equal to 4, and now you redefine bar2 dot class dot b equal to 3, what's your guess?
4, 3, 4. 3.
2 for 4, 1 for 3.
8.5.
Random undefined behavior.
4. So when you define it in the instance, it gets stick to the instance.
But if it's in the instance.
As it should be.
First searches.
No, it should not.
So this is you don't like this, I know. I know.
Come on. This is just hiding the pointers behind the.
Yes.
Come on.
What are pointers anyway?
Yeah, exactly.
I have another question.
Yes,
You
sir,
create function for the class instead of create function for the instance. And then,
Yes. So the functions are always defined in the class.
I mean, not like there's a no like self thingy, and then you can call like a class dot something.
Yes,
to that.
you can.
So the take-home message is basically don't do this.
Okay.
Because this is
Yeah,
going to go
it's a
horribly wrong.
initialization value for your members if you
Yeah,
want.
do the init.
So
Can I access the B directly from the class, or like the capital proof?
Yes.
That's all.
So before we quit, I wanted to show you quickly the singleton. We'll go back there next time. So, and before we do that, we're just gonna print this. Okay, I'm just creating 2 objects of the class foo, and I'm printing when new is called, when init is called, and when del is called, just to understand what's going on. Okay, and let's clear this first, and go back and run it again. So del new init. The del are there because I called it the first time. You reinitialized the interpreter when I called it the second, deleted the objects both, and then started interpreting the Python code, right?
That's not disgusting at all.
Huh?
Super weird.
It's super weird, but it's good to see it because if you expect the del to be run at any time, you'll be wrong, right? It's going to be run whenever and whatever the interpreter decide to do, or the interpretation of the interpreter that you're currently using, to better say.
So the args and the args, so the K args and the args are needed there because you need for the super.
All right, so this is usually actually here not needed. So I'm just putting it here for good conventions. You don't know what's happening in the super. Usually, you don't know what arguments are passed, so you just pass them back. All. But if you're extending object, you know there's no argument, so you can just ignore them, right?
Is the del being called when the interpreter shuts down?
When the interpreter shuts down, in this case, was called in that case because it didn't get destroyed. Why? Because I have an open console right here, so it wants to keep the object in memory until I'm finished with it.
So if you write exit or control D now, then it should call del, right? If you do command D or exit.
I don't know if it works in Pythonista, but yeah, we can try. But then you get no output. But then, of course, you can recall them and know the del are there. Don't try to second guess it. Just don't use it.
Rely on it.
Just don't rely on it. And if you really have something that you can do nowhere else, maybe use del.
But takeaways like the init is actually like used
Init is used everywhere and all the time. New only if you have to do something specific. And we're gonna see this last thing I want to do today, a singleton. So how do I proceed to create a singleton? When first of all, I want to create an instance variable in my class or I put the instance I want to use. And that's the only instance I'm going to have. So whenever somebody asks me, give me a new object, well, then I'm going to call new. And then I'm going to check, is my class instance equal no? Right? This is lazy initialization. If you've never seen it, lazy initializing a variable means I don't do it here. I do it when I first call it, so that I don't keep stuff around. Yes.
What's the difference between equal, none, and this none?
That I just should have wrote is. That is what's wrong with it. It actually works, but it's not good. So
Why is it good?
because it doesn't work always. But in this case, I tested it and it works. So this last instance is known. If it's known, then you can first initialize it. And this is how you call the super new. When you pass this CLS, why CLS? Because this is a class method and not an instance method, right? So the first argument is always basically the class. It initializes a new instance for you. This behind the scenes is just called type with class. That's what it does. And then, well, I increase my counter to see how many people actually got an instance from me. This is just something that I'm doing to demonstrate how it works with the singleton. It's not part of the singleton. So the singleton ends here. And then I return the instance, whatever that is. So if there was no instance, I initialize one and I return it. If I had an instance already, I just return it. And I increment the counter to know I have one more people pointing at my instance. Okay. So then in the init, well, I just print the counter again for show, and then I return. I call super, because if somebody implemented other stuff, I just want to call it, right? There's no use here. This is again the init. You will leave it completely in this case. Does it work? So what we're doing is creating a first singleton and then printing the counter. Then creating a second singleton and then printing the counter of the first and of the second. Then I'm creating a third and I'm printing the counter of the first. What will I get? 1, 2.
And in between a lot of init counter.
1, 2, 3. And the 3 is on the first, the second, and the third. Of course, there's only one instance. So everything that is defined on the first is stick to the first, to the second, and the third, and so on. Right? Any questions on this?
I don't get how you access the counter if it's actually class of instance dot counter. Why can you then access it like from the object as a dot counter?
Because A is class of distance, B is the same class of the distance, and C is also the same class of distance.
So if I, after that, I say print B dot counter, C dot counter, they are also 3.
They're all 3, right? And that's what I'm trying to show you here. When you use a singleton, what you do is actually you stick the instance to the class definition. Since this class, again, is an object in the heap that is very well defined. There's one place where this is defined, right? If I stick this instance in it, then I know where to find it, and I have only one instance around. Whenever I create a new object with this new, I'm not creating anything, I'm just returning the same object to you. And if you're 2 different clients of my library, you get the same object and you get the same values inside. So for example, if this was a database access library, you would get the same factory that creates then your connections. And then I can keep count of how many connections I have around, because again, like this, I have a counter that is global, right? So I can know I gave 3 instances to you, 5 instances to you, and you're going to connect. Now I have 80 instances and give an exception to the next guy because I cannot support more than 80 instances.
Yeah, return none, what does it mean?
Where?
Return CLS dot instant, it means return none.
No. If is none.
No, the last one.
Return
None.
CL instance is never none. Because if it is known, I initialize it.
In line 7, you initialize class of instance is equal to.
So if it is known, I initialize.
Okay, yeah.
So only if it's not known, I just return it. Make sense?
But if I after a class, I put instance and some other variable, and then I define also for this other variable, also super and also counter. then which one do I call?
Sorry, from the start. What do you want to do?
It's weirding me out a little bit. Like if we have another like we how we instance the same thing with another variable, let's say not instance, and then we give it a counter as well, a dot counter. Then which one do you access when you in A, for example, A dot counter? Which one does it access?
All right. If it is an instance member, so if you define it in the int, right, it still belongs to the same CL instance that is defined up here. So you have only one instance, therefore you have only one instance member defined that way. Does it make sense?
Yeah.
So
So
you
if I
can
have
do
more than one,
you can do anything you want in the init. You will have only one copy of every variable that is defined here because you have only one copy of the instance.
But
Yes.
you call the init method 3 times now.
Right.
You don't want that.
Yes, and this is again is just to show you that
You will need to do
the
the same
counter
thing.
increments. But I'm not. If you assign something here, of course, with the value, let's get called 3 times. Yes.
Yeah. So you want to do the same if class instance
You
check,
do it basically up here, the initialization. That's what you want to do.
and then remove the init.
Yes.
Or not.
This is just again for sure. You don't want that in your singleton. Yes.
Question: why is new not a static method?
Wait a second. Somehow this has died. Alex?
Yes.
Okay.
Why is new not a static method?
It is a class method. CLS?
I don't think I see your finger.
Sorry, but line 5, def new SLC, CLS, sorry. The new method is always a class method. You don't have to mark it as such.
It's built into the name new. It's special to the name new.
Exactly.
Okay, second question. What is the superclass of any class? Is there some generic object like in Java, and where every...
Absolutely, there is object, which is the superclass of anything that you don't define as a superclass. And next time I want to see, let's see if we get down with the container. The one thing I wanted to do is basically how super works and how it works when you give it more than one class, because Python supports multiple inheritance. And it's usually something that messes up your brain if you try to understand what get called before and what gets called out.
really disgusting.
So, but we'll get to the end of that, and we show how actually super is working step by step, right?
I don't have multiple inheritance in the code.
Yes, you have.
It's very useful multiple inheritance in Python, particularly because you can write out the functionalities in things that don't depend on the superclass.
I have to have it because I inherit from
Okay. Private squabbles, please outside the class. Okay. Any other question?
So to sum up, if I understand correctly, so whenever you define a class, so everybody, so you can add things, change things, and stuff.
Exactly.
It's flexible, just a bit sense of unsecure for me.
Yeah, that's generally Python. It's very easy and very unstable sometimes.
Yeah, because
can we do a special lecture on
You have to do your own checking, right? If you want, nobody says you cannot do type check, but you have to do it. You have to put is instance and put the type. But if you don't want it, because again, if you don't do it, it's not executed, it's faster, and you can actually apply the same function to different types if it works. So it's actually its own advantage. It's up to you.
Okay.
Right?
Are we going into reference and copy and stuff also?
Reference what?
References and copy and so on with objects?
We can, yeah.
Because that's always ruining everybody's.
Deep copies, shallow copies, and all this stuff. Yeah. Let's see. I mean, I wanted first to put the ground of the syntaxes and the interpreter and how multiple superclasses work and so on and so forth. Once we've covered the basics, then we're going into other special topics. Deep copying is probably one of the good ones. Also, value passing and reference passing and so on. Immutables, mutables. Right.
Can we
Good.
also touch like Python compilers? And
No, that's mine. You can touch
Here's
it.
code.
Yes. Python compilers. Let's see. I mean, there's a lot. We can talk 3 years about Python. There's a lot of ground. Let's see how far we get with the first 4 or 5 lectures. Okay. Good. Thank you.